Right. Fingers crossed this is now working. If it's not, we'll just have to leave it for tonight again. Everyone's installed, everyone's good to go. Excellent. That was half of the main goal for tonight. So now that we can all compile C++ programs, let's go on and talk a bit more about C++. And first of all, I'm very quickly going to go over something we talked about last week, which is if statements, because they're very central to how we do things on computers, making decisions. Really vital. If you've done any sort of programming before, then the way if statements work in C++ is going to be very familiar, because it's basically the same as most other programming languages out there. So hopefully for quite a few of you, this will be like, yeah, I know all this. Get on with it. Come on, one more. Right, so if statements, absolutely vital for building programs. We really cannot do anything at all interesting without some form of if statement. And the way what we have in C++ is this keyword if. And we say if some condition. So some condition is Boolean, that is something that's true or false. Actually, strictly speaking, it's something that can be converted into a Boolean, something that is, as they say in other languages, truthy or falsy. So we have if, we put the condition in some round brackets, and then we have a list of instructions to execute if this condition is true, and we put that list of instructions in these curly braces. This is a block of statements, a block of instructions. So if the condition is true, it's going to execute the statements that are in this block. If the condition is false, it's just going to jump down here and it's going to ignore everything you wrote in there. What if we have more statements we want to test? Well, we have this else if that we can attach to an if statement. So what does that look like? We say if some condition. So if this condition is true, it'll do something. Else if this other condition is true, it'll do this. So first of all, we'll test this condition. If that's true, we do this list of instructions, and then we jump down there. If this condition is false, it's going to try testing this second condition. And if that's true, it'll run these instructions. If neither condition is true, well, we're going to skip the whole block, and our execution is going to continue down here. We can have as many else-if statements as we like. You have pages of them if you want. Wouldn't necessarily be a great thing to do, but it's possible. But one very important thing to bear in mind is that conditions are evaluated in the order that they appear. So if we had 3 or 4 of these, it's going to test the first condition, and if that one's true, it's going to run the first block and then skip everything else. And if the first one is false, it's going to test the second block and then run that. So conditions are tested in the order that they appear. This is really important. So it's possible that you have multiple conditions that are true. It's going to run the first one that happens to be true. Again, it's pretty much how all programming languages work, but occasionally people who are new to these things find it a bit surprising. They think a different block of code should be executed to what actually is. But it's going to test the conditions in the order that you write them. Finally, if none of the conditions are true, so if we have if, else if something, else if something else, else if something else, else if. Finally, we can do something if none of the conditions are true, and that's we can just use the keyword else. So here we've got what we had before. So if some condition is true, we do something. Else if this other condition is true, we do something else. Do a second thing. Finally, that was funky formatting there. Finally, if neither of these conditions are true, it's going to execute this final else block. So if this condition is true, it's going to do this, and then jump down here. If this condition is false, it's going to test this condition. And if this condition is true, it's going to do that, and then jump down here. Otherwise, if neither of these things are true, it's going to execute the code in this else block, and then carry on down there. So, if else, right? Absolutely fundamental sort of component of every single meaningful program that there is. A very quick example that I went through last week, and I should have remembered that it turns up very, very small on the projector. There are plenty. If you're sitting at the back, and this is hard to read, by the way, there are lots of spaces up front. So don't be shy if you, like me, you don't have great eyes and you want to come and see the screen a bit better. But anyway, we've got. Well, maybe somebody can tell me. What is this line saying? How do we translate this line of C++ into English? Void greet, open bracket, std, : string, name, close bracket.
Oh, that's not the record question.
Oh. Anybody want any volunteers, or am I just going to be really mean and pick on someone? Yeah. Well, what's the whole line, first of all? The whole line is, what do we...
It's a greet function.
It's a function. Yes, we are declaring a function here. And the function is called...
Yeah.
Okay, excellent. So we're declaring a function here. A function named greet, which returns nothing, and which takes a single parameter of type standard string, and the parameter is called name. And then, so this is what we call the signature of the function. That's its name, its parameter types, and its return type. This is the signature of the function. And then we follow that with a block. That's the block of instructions to execute when this function gets called. So that's what this little opening curly bracket here does. So what instructions do we want this function to actually perform? Well, the first thing we're going to do, it's an if statement example. So we're going to use this keyword if. So we've been given in our function, some of our input data is a name of type standard string. Remember, I was going on and on about the importance of types in C++. We need to know the type of all our input data, of all of our data in our whole program, actually. So this parameter, this bit of data name, has type standard string. That's just like a list of characters, some text. So if this name is equal to Tom, and the way we test whether two things are the same in C++ is by using this equals equals operation. So remember I was saying last week that a single equals is assignment. That's used to change the value of some data, change the value of a variable. If we want to test whether two things are the same, test for equality, we need to use a double equals sign. And again, the same goes for lots of programming languages, sort of C-derived programming languages. So probably a lot of you are already familiar with this. So if name equals Tom, we're going to print hello Tom. Otherwise, we're going to have a second test. We're going to say if name equals Ollie. Hello Ollie, I resisted the temptation to be rude. So first of all, we're going to test the name is Tom. If it is, we do this. Otherwise, we do this line. And if neither of those things are true, we print a message saying, I don't know you. Test whether it's Tom. Otherwise, we test whether it's Ollie. Otherwise, we print out, I don't know you. This is a really, really secure password system, this. So this is our greet function. We've now got our main function. Always returns an integer, remember. So now we're going to call our greet function and we're going to give it the data Tom. So it's going to jump up here. It's going to say, is the name that you gave me the same as Tom? And well, yes, it is. So it's going to execute this line. It's going to print out hello Tom, and then jump down here, and the function's finished. What's going to happen when I call greet Stephen? It's going to print I don't know you. It's going to say, is Stephen equal to Tom? No, it's not. Okay, try again. Is Stephen equal to Ollie? Yeah.
Just wondering, in your function, you find the return as void.
Yeah.
So that means it will return it, but then it when it print out, it does return the string. It returns strings like hello Tom, hello Ollie. So I don't understand.
Okay, so you're saying the function, I've declared the function as returns void.
Yeah,
That is,
yeah.
the function doesn't return anything. And that's correct, the function does not return anything. What we're doing is we're printing something out. That's not the same as returning a string. This is like a print function, it just sort of sends it to the output of your computer, right? It's like a sort of external thing that is...
I mean, to put it more succinctly, a function only returns something if you see literally the word return followed by something. That function does not have a return in there anywhere, right?
Right.
Yeah, so this function isn't returning any strings. What it's doing is like basically telling the operating system, like, put these characters on the screen.
Okay.
Yeah,
So return and print are different things.
precisely. Return and print are quite different things. It just so happens that most of my examples have used print because that's something that works well on one box.
So a return is it returns a function.
No, so what return does is it returns some data from the function. Okay, so functions can have inputs and may or may not have an output. So in this case, this function doesn't return any data to the place we called it. What it does is it says to your computer operating system, hey, just put this on the screen for me. But that's different from returning like some data inside your program. Yeah. So, if we try and greet Stephen, it's going to say, are you the same as Tom? No, you're not. Are you the same as Ollie? No. Okay, so then we're going to execute the else block, and it's going to print out, I don't know you. And then we return 0 because main has to return an int. So we return 0, as we talked about a couple of weeks ago. Is everyone clear on if statements? Awesome. One of the two major building blocks. The other one we'll talk about shortly. So last week I left you with an exercise. This is an absolutely classic fundamental programming exercise that comes up again and again, right? It's used as an initial screen on a lot of interviews. It goes by the name of Fizzbuzz. This is not exactly the form that it always appears, but it's very, very similar to a lot of programming exercises you'll see. So did anyone have a go at this? Yeah, a couple of people. Yeah. Okay, who was successful in making this work? Everyone who tried it. Well, that's excellent. Okay, so what I wanted you to do is to write a function called Fizzbuzz, takes an int, and then perform a series of tests on this int. So if it's exactly divisible by 3, we print fizz. If it's divisible by 5, we print buzz. If it's divisible by both 3 and 5, we print fizzbuzz. Otherwise, print not fizzy or buzzy. And then I suggested a few values you might want to try it with. What's it going to print for 99? Fizz. 125. Is 125 divisible by 3? No. So it's going to print buzz. 225, I can save you some time. That's divisible by 5 and by 3, so it's going to print Fizzbuzz. And 1024, it's going to print not fizzy or buzzy. Do you know there's a real shortcut for testing whether something, just mentally, whether something's divisible by 3? All you need to do is add up the digits repeatedly. And if you get 3, 6, or 9, then the original number was divisible by 3. Something like, I remember like my teacher, when I was about 10, telling me that. I was like, oh, that's brilliant. Anyway. So yeah, 225 is divisible by 3. 2 plus 2 plus 5 is 9. It's also divisible by 9. There you go. Not just C++ in this class. There's all sorts of interesting things you learn. So,
do that exercise, sorry. Is there any chance we can go through it? Because it's not easy to come on Thursdays.
well, I was just about to show you my solution to this exercise. So, what's the tricky, for the people who did it, was there a tricky bit? Something that was kind of a bit where you realise, actually this isn't quite as obvious as it sounds.
So the tricky bit was how to do the and, whether it's like both of the ampersands or and, because there's apparently a difference between bitwise and the other one.
Oh, so you're saying that the difficulty was testing whether the 3 and 5 are both true?
Work, yeah.
That wasn't what I thought the difficulty was going to be, actually, but
Sorry.
that's okay. That's okay. So I'll show you there's like a shortcut for that. Basically, I'll show you in a second. What this exercise was intended to demonstrate and intended to get you to notice was this thing I was saying about how the order of the conditions of your ifs and else ifs are important. Because if you just code it exactly as I've written on the screen, you say, okay, if we're divisible by 3, we print this. Otherwise, else if we're divisible by 5, we print buzz. Else if divisible by 3 and by 5, we print Fizzbuzz. Else, print that. Okay, that would be like a straightforward transformation of this English into C++, which unfortunately is not going to work. Because if something is divisible by 3 and 5, then it's going to hit the first condition, right? It's never going to get to the third condition because the conditions are tested in order. So again, that's really the point of the exercise. Sorry, did you? Oh, I thought it was a hand. So I guess it wasn't really a trick, but just kind of get you thinking about was to just realise that you have to be a bit careful about the order in which you test these things. So this is my solution to the problem. So this I% thing, this is the modulo operator I mentioned last week. It tests, well, it gives us the remainder after dividing one integer by another, right? So 10 divided by 3 goes 3 times with remainder 1. This is like we did in like primary school and have probably forgotten because I did. But that's what it turns out to be important for all sorts of things, cryptography and stuff. Important enough to be built in to the language. So we can say I% 15, or actually let's start down here, I% 3. So this is the remainder when we divide by 3. So 5% 3 is going to give you 2, because that's the remainder when we divide by 3. Divide by 5 by 3. But this is a handy test for whether we have something that's exactly divisible by another number, because if it's exactly divisible, the remainder is 0, right? 12% 3 is going to be equal to 0, because 12 is exactly divisible by 3 with no remainder. So this says, ignore that bit for a minute, if I% 3 is equal to 0, that's if I is exactly divisible by 3, we're going to print fizz. Else if it's exactly divisible by 5, we'll print buzz. Else, we'll print not fizzy or buzzy. The trick, if you can call it that, is that we need to do this test for 3 and 5 first. So the way you can test for something that's divisible by 3 and by 5 is because if it's divisible by 15, 3 and 5 are co-prime if you know what those mean. But so if something is divisible by 15, then it must be divisible by 3 and by 5. So we test, is it divisible by 15? No, it's not. Okay, what about 3? Okay, what about 5? None of those? All right, we'll print not fizzy or buzzy. But we have to do this one first, because every number that's divisible by 15 is also divisible by 3. It has to be. So if we had these two conditions the other way around, we'd never get to the Fizzbuzz case. Right? So again, this is kind of a really, really almost cliched problem or exercise for programming. It's just basically they want to know, do you understand this thing about the order of if statements and whether it's important? So I thought I'd throw that in week 2, which was perhaps a bit nasty of me, but it seems like the few people who tried, or everybody who tried it, managed to get it going successfully. So well done to those of you who did. Okay, any more questions about Fizzbuzz, about if statements, about last week's? No. Cool. All right, let's talk about standard vector. So this std : prefix in C++ terms, it's shorthand for standard. It means this thing called vector, which belongs to part of what we call the standard library. That's like a repository of code, a library of code that comes with your compiler. So it's always there, it's always available to use. And everything that lives in this standard library has the prefix std : Now, standard vector is one of, if not the most useful type that is provided, useful thing in the standard library, right? It's brilliant. It's amazing, and you should all use it whenever possible or whenever appropriate. What is a vector? Well, first of all, if you are a mathematician and you know what a vector is, you know, an element of a vector space, that's not what this is. So don't worry about that. This is sort of really, I don't know how it came by the name vector. It's a strange thing because it's not related to mathematical vectors. What a vector in C++ terms is what other languages might call an array, or perhaps sometimes an array list, sometimes even just a list. It's a collection of things of the same type. So we can have a collection of integers, we can have a collection of floats, we can have a collection of strings. We can even have a collection of collections of vectors, if you want. Sorry, collection of collections of ints, a vector of vectors. That's possible. So a vector is a collection of things that all have the same type. Collection of values. You can have a vector of ints, a vector of strings, vector of floats, vector of bools, sort of. And vector is useful, essential almost, whenever we want to hold a bunch of things, a bunch of data of the same type, right? So if I wanted to write a program that collected the names of everybody in this room, I would use a vector of strings. right? Everybody's name is text. We store that in a string. There are, I don't know how many of you, quite a few of you. So I don't want to have to rewrite my program every time someone new comes into the room. So instead we use this vector type. A vector is a collection of values. But actually, we can have different kinds of vectors. As I say, we can have a vector of ints, a vector of strings. Vector is an example of what we call a generic type. Now, these generic types are actually quite tricky to write yourself. That becomes quite advanced. But actually using them is relatively straightforward. And I'll show you an example of that on the board in a second. One thing to note is that because vector is part of the standard library, it's not built into the language, we need to tell our compiler that we want to use this vector type. And the way we do that, just as in Python you might use an import statement, well, in C++ we use this instruction #include. So you say #include and then the word vector in angle brackets. And just to do that at the top of your source code, and then you can use vector. Use this std : vector type. Yeah.
So vectors needs to contain identical items. We can't mix strings with integers and in a vector.
Vector, yes, correct. When you say identical items, they don't all have to have the same value, but they all have to have the same type.
Yeah, exactly.
That is
So
correct.
We can't just do integers and
It's
strings.
a homogeneous container, yes,
Okay.
correct. It's also worth mentioning for those who are interested in these things a little bit more advanced, but vector is actually even better than you might think. Vector is great because it's in many ways the simplest container and the easiest one to use. There are many, we call it a container, that is, it contains other values. There are actually loads of different containers in the standard library. I think about a dozen. Vector's just one. But actually vector is the best and the fastest and the simplest. And as computers get more advanced, this is kind of a funny thing, but vector is even better now than it was sort of 10 years ago or 20 years ago because of the way computers are getting faster. They have larger caches and stuff. The way vector works is it lays out all the elements, that is, all the things that are inside it, lays them out next to each other in memory, and this makes it really, really, really fast to use in practice. Super duper fast. So later on, when you come to learn about these other collection types and you're starting out your program and you're sort of wondering which is the best type to use, the answer is almost always vector. Vector is brilliant. We love it. But that's for those who are looking a little bit ahead. So when I mentioned, and we had the question there, when we use a vector, we have to specify what the type of elements that this vector will hold. And the way we do that is, hopefully that's come out on the screen, we need to use angle brackets. So we say a vector of some other type. So we say std : vector, and then we put the word int, well, say, in angle brackets, to say we want a vector of integers, a collection of integers. Or we might say standard vector, angle brackets, standard string, to say we want a vector of strings. And you can use pretty much any type in a vector. There are some requirements on the type, but pretty much anything that you're going to use, certainly in your early C++ careers, you'll be able to store inside a vector. Oh.
Excuse me, can we be getting copies of the slides?
I will make this. I will make the PDF available. I'll put it online, and you'll be able to download the PDF.
Or you can watch the YouTube as well.
Or you should be able to watch YouTube now. Yeah.
I'd rather have the PDF go through it until I get to
Let's keep.
So let's have a little look at an example. It's all my bullet points appeared out of order, but never mind. So here we're saying we want to use the IO string facilities of the standard library. That is, we want to print things out. We're going to use strings as well, and we want to use this vector type. So we need these include statements at the top to say which standard library facilities we want to use. IO stream, string, and vectoring in the case of this example. And now this is a variable declaration that we saw last week. So this is declaring a variable, that is some data in our program. And when we declare a variable, first of all, we write the type. So every bit of data has a type. In this case, the type we want to use is a vector of integers. That is a vector, and then we write the type that the vector needs to contain in these angle brackets. So again, if you're familiar with Java or C# or whatever, that's the same generic syntax as in those languages. In fact, they copied it off C++. Swift as well, I think, uses angle brackets for generics. So we're saying we've got a vector of int, and we've named this piece of data integers. And we're saying it's equal to, so this is our initial value. Remember when we were writing our variable declarations last week, we said the type, the name, and then the initializer. The initializer in this case, we're saying it's equal to 1, 2, 3. So this is a group of things, a collection of things. So we put it in these curly braces. So a vector of integers, and we're initializing it with 1, 2, and 3. So our collection is going to have 3 elements. Those elements are 1, 2, and 3. That's what this statement is saying. So now we have a second variable, second piece of data in our program. This one is called strings. The type is a vector, a standard vector of standard strings. So a string, as I've said, is just some text, just the sort of computer sciencey name for it. So we've got a vector of strings. We've named it strings. And then we're initializing it, this time instead of the numbers, 1, 2, 3, these are ints, we're initializing it with the words, 1, 2, and 3.
So the 1, 2, 3, is that like an array?
It's exactly like an array, yes.
Well, that's not like in the square brackets, that's inside the curly braces.
Yeah, so so C++ has these like built-in, what we call built-in arrays or language arrays. They're actually really awkward, and they're like a sort of legacy thing almost from the really early days of C, and they're really awkward to use, and so we prefer not to use them because they're really hard to get right. So vector and another standard library type that's actually called standard array, which we'll introduce later. These are much better alternatives to using what we call these built-in arrays. So built-in arrays are like a thing from C from 40 years ago that nowadays are a bit old hat and we prefer not to use them. So when you have a collection of things, think standard vector, a collection of things of the same type.
So what about when you use integers and then strings and then you define, this is like the name of the list or the name of the array?
Exactly that, yes.
So what do we want to call it? We can call it like integers, or we call it pink elephant.
You could call it pink elephant, absolutely. Yeah, yeah. So this word integers, that is the name of this variable. Yeah, yeah, very good. So we've now got 2 vectors defined, a vector of int and a vector of standard string. We've called them things integers, called these variables integers and strings respectively. We can add new elements to these vectors. We can modify the elements of a vector. We can add new things into a vector. All right, this is something you can't do with the C arrays, by the way. And to do that, we use this command push back. So we push a new value into the back of our vector. So if you think a vector is just a load of elements next to each other, all these values that are inside it are just next to each other, one after another in a big long line, and we want to just push something onto the back of it. So push, that is, insert a new value into the back. So we're going to modify our strings variable. We're going to use the command pushback. So strings dot pushback. This is a method call for those who are familiar with that in other languages. So we're going to insert a new value into the end of our strings vector, and that's going to be the word for. So our strings, after we've executed this instruction, our strings vector is going to contain the words 1, 2, 3, 4. Yeah?
Isn't that bad memory-wise? Because it might have to be copied and put somewhere else and there's no space.
Yes, it might reallocate internally.
It might reallocate.
Yeah. Yeah, yeah.
So this is not the ideal way to do it. Would we normally would like initialize the whole thing and then put them somewhere? You know what I mean?
This is meant as a demonstration of how to use it. If you're worried about, how frequently things reallocate, that's a little bit more advanced than we need to worry about today. But you are absolutely correct that, if we knew that we wanted 4 in our vector, well, we could have just added it to the initialization there. That would have been a single allocation. Secondly, vector, if this is, the rest of you don't worry about this, vector actually has a method that's .reserve, and that lets you set the allocation up front. Not something you should use all the time because it can actually make things slower if you get it wrong, but it's sometimes, in cases that you really have to optimize, it can be used to avoid frequent reallocations. Okay, the rest of you can tune back in now. So pushback adds a new element to the end of our vector. And this is super duper efficient for vectors, notwithstanding this reallocation thing. This is super duper fast. The other thing we can do is we can ask a vector how many elements it contains. And the way we do this is with the size command. So we say string.size, and that's going to return a number. That's the number of elements in this vector. So we've initialized it with 3 elements. We've added another element. So this is going to print 4, as you would hope. I don't know whether to pose next to it. So we can add new elements to the end. We can query the size. Pretty useful things. What about accessing the elements? Well, we can do that with these square brackets. So lots and lots of different kinds of brackets that we use in C++. The square brackets are used for accessing the elements of an array type, like a vector.
Sorry, I'm slightly confused though.
Sorry,
Because you, oh.
I'll show you an example in a second, and we'll hopefully become clear. Unfortunately, the build order that things have appeared isn't what I thought it was going to be. So we have a vector is like a collection of things. We can say, okay, give me the element that's in the 5th position of this vector. Right? Give me the element that's in the 10th position. Give me the element that's in the millionth position. Sorry?
So we only have 4 in the example.
Well, in the example we only had 4, yes. One thing really important to bear in mind, and pretty much every modern programming language does this, I think, but some people are still surprised. C++ counts from 0. That is, the first element in our vector has index 0. Right? This is something that's important to bear in mind. It's really easy to get wrong. So common, in fact, we have a name for it. You can get an off by 1 error. Right? This is like so exceedingly common. It must be like the most common bug there is in programming. So always bear in mind, C++, like C and all those related languages I keep talking about, C#, Java, etc., we count from 0. Index of the first element is 0, the index of the second element is 1, etc. So here's our strings vector from the previous example. 1, 2, and 3. Words 1, 2, and 3, that is. And now we use the name of our vector, the name of this data the name that we've given to this variable. Say strings, and then in square brackets we say, please give me the element at position 0. So in this vector, what is the element at position 0? Yeah, it's the word 1, because I thought I'd be really confusing and demonstrate this propensity for off by 1 things, because as humans we usually start counting from 1. Yeah. But computers, or C++ anyway, starts counting from 0. So it's something you've always got to bear in mind. So this says, give me the element of position 0. And we're going to pass that to our output stream. So this is going to print the word 1. I'm going to print the letters O-N-E. We can also use this to modify the elements of our vector. So this is saying, in my strings vector, get me the element in position 2, and set that equal to the words 44. So what is the element in position 2? Well, it's 0, 1, 2, so the word 3. And it's going to replace that with the word 44. So what is our vector going to contain after we've executed this line? How many words is it going to contain? Well, how many elements is it going to contain?
It's still going to be 2, isn't it?
It's still going to be
2.
how many? How many did it start with?
I don't start. It started with 3.
It started with 3 elements. They're numbered 0, 1, and indices, right? So it's still going to have the same number of elements because we haven't added anything. We haven't done a push back. All we've done is change the value of one of the elements.
Oh, well, Because I was looking at that thinking the output was going to be the element 2 and element 4. I know what you're saying, that is now equals
Yeah.
then,
So the vector is still going to have 3 elements. Those elements are going to be the word 1, the word 2, and the words 44. This is super duper important, right? This next bit. Yeah, I suspect it's about what you're about to ask, but go ahead.
Can I set string 3 to somewhere?
This is super duper important. It's so important it's perhaps the first thing I've written on these slides in red. Right? This is to get you to pay attention. If you try and access an index beyond what the vector contains, really, really bad things are going to happen.
Like not reading terms and conditions for a source code.
Really bad things are going to happen. Right, so this vector contains 3 elements. That's element number 0, element number 1, element number 2. Those are the indices, the indexes. Right? What happens if we try and ask for index 3? Well, it doesn't exist. Bad stuff is going to happen. If we are lucky, our program will crash. If we're lucky.
As in I could break my computer.
No, you can't break your computer necessarily. Right, but what? No, well, hang on, it's not that funny. No, it's not that funny because what can happen is your program will continue running, but you've asked for element 3 and it's just read some random piece of data that whatever happened to be lying where that element would be, right? So, and then, you know, you're trying to run your program and it's full of junk. Now you're saying, can I break my computer? Well, no, you can't, because you're not nasty and malicious and trying to break your computer. But if you are running something on, say, like a web server or some computer connected to the internet, when there actively are very nasty, mean, nasty people that are trying to break your software, trying to break into your computer, these things, like out-of-bounds memory access, which is what this is, this gives people, presents a possible security problem for your software. This is actually like a really bad thing, right? I'm not kidding with bad things will happen. Bad things can happen if you do this, if you attempt to access an element outside of the range that your vector actually contains.
Why would it go to search for something that's not there in the first place? Shouldn't it just go to what's coming?
Okay, so that's a good question. Why, like, what it could do, it could just check. Every time you ask for element 2, it could go and check, how many elements do I have, right? And if it's got more than 2, sorry, if it hasn't got at least 3 elements, so index 2 doesn't exist, it could just like terminate your program or give you an error message or whatever, right? The reason that it doesn't is because C++ is obsessed with performance. Right? Obsessed with making things as fast as it possibly can be, which is really, really important if you're writing a computer game or you're writing some algorithmic trading software that needs to respond in not even milliseconds, like microseconds. Right? Then you need the fastest possible programming language there is, and that's pretty much C++. Right? So it doesn't do these checks because the checks would cost time. What are you going to say, Michael?
There is a bounds checked version.
But, if you find all this scary and terrifying, and it is a bit scary and terrifying, it's not going to break your computer unless you're, upload your programs, run them on the web. But if you find this scary and terrifying, I have good news for you. Instead of using these square brackets, there is a command which is .at. So we'd say strings.at And then in round brackets, we put the index that we want to access. So here we'd say strings dot at 0. That would return the element at position 0. So it does the same thing, except it makes sure that that element actually exists before it tries to access it. And if it doesn't, well, for now, it's just going to crash your program, which is actually, but it will give you a nice error message telling you exactly what you did wrong. It will say, you know, you tried to access element 66, but there are only 22 elements in your vector, in this vector. So this is the kind of nice looking way with the square brackets, but when you're getting started, it can be better to use this .at member function, because it just gives you nicer error messages and tells you what you've done wrong, rather than your program trying to continue to run and using bogus data, or crashing, or as it might do with a really unhelpful error message. Yes?
You can use the if statement, what we learned previously, to sort out the error messages.
Oh, of course, you can absolutely say, for example, if you were here, you could say if vector.size is less than 3, we'll do nothing. Oh, sorry, no, let's try it the other way around. If vector.size is greater than or equal to 3, we're going to run this, otherwise we do nothing. That is exactly what the at function is doing inside. It's using an if statement. Yeah, that's precisely what it's doing. And you can do that yourself if you prefer.
This is how you can introduce viruses into your computer.
Not viruses necessarily, but you know, when people kind of break in and steal, you know, millions of usernames and passwords, it will be security exploits, these kind of things that allow them to do that. Not necessarily exactly this, but I haven't heard of that one. But there are so many examples out there. Yeah.
And when we want to print out, because in Python, for instance, it's going to be print and then strings, and it's going to give it an terminal. When we want to print out the vector that we created, how do we do that without a loop?
There is no way of doing it without a loop.
Okay.
In fact, even in Python, it's going to be using a loop internally.
Yeah, but we just
But there is no built-in method to do it in C++. But on the next slide, I will show you how you can write that yourself. So we can access elements of our vector using their index. The indexes count from 0. This square brackets thing is a bit scary. I mean, you don't have to worry about it for programs you're just writing yourself if it doesn't work. It can, you know, in the wild, if there are bugs in your program, if you're trying to read an element that doesn't exist, it can be problematic. The way around that is there's this .at command, .at method, member function.
How is that written? Is it literally .at?
.at, and then in round brackets you put the number, the index that you want.
round brackets, not square.
Yeah. So
If you can do that, why do you bother using square brackets?
because square brackets look nicer.
Faster.
So yeah, I should have put it on the slide really, because so what you would say. Could get a pen that works. Let's try again. So we say strings and then .at and then the index that we want. Equals 44, we say. Now, if we asked for element number 17, which doesn't exist in our 3-element vector, this would, in this case, terminate our program with a message saying, you tried to ask for element 17, but I've only got 3 elements. So it's a sort of slightly slower because it has to do the checks. So slightly slower, but more user-friendly.
And does it matter whether any of the white spaces are?
No, C++ really doesn't care at all about white space. I had to put it on 2 lines because the board is only that wide, but actually you could write it like that in your C++ code and it wouldn't care at all. Yeah, so it's not like Python, for example, is a language that really, really cares about where you put your spaces, but C++ doesn't care at all.
Can we provide a default value at the end of at if there's nothing? So, for example, if I don't have X element, I just want default name, Kate or whatever. Can we do that?
No.
Okay.
No. You could write such a function yourself.
Sure.
Right. Yeah. Yeah, very good question. Okay, so how on earth does this work? At is a function, has a return value, and then I'm setting that equal to something. Might be next week, but more likely the week after, we'll talk about references, and that will make it clear how this works. But for now, just it's magic. For now, a couple of weeks it will become clear. Yeah.
As I enter the command strings, there should be two, but I get something and or and I don't know either.
Okay, we'll have an exercise in a couple of minutes, and then I'll come and have a look. But let's just go through something else that we can do with vector, which makes it incredibly useful. And that is we can perform what's called iteration over the elements of our vector. That is, we have a collection of things. We can perform an action for every element of our vector. For each element of our vector, do something. And there's a word in the language, it's not very clear on the slides, but it's the word for. So I've used a vector of integers this time, vector of int, called it myvec, and I've initialized this vec with 3 elements, the integers 1, 2, and 3. Now, we have something new. For each int in my vec, I want you to print it out. So I'm going to take my vector, that's this guy here, and I want to examine every element of that vector. Do something for each element in that vector. And I'm going to name, well, actually what I'm going to do is I'm going to take a variable I, and I'm going to set I equal to, first of all, to element 0, then to element 1, then to element 2. So I'm going to perform this action 3 times, because my vector holds 3 elements. Okay, so this is an example of a loop that is, as I say, performing an action multiple times. So the first time we enter, we're going to create what's called a temporary variable called I, and we're going to set that equal to the element in position 0. So I is going to be equal to 1. So we're going to print out 1, followed by a space. Then we're going to jump back to the top. And now we're going to create I again, and this time we're going to set it equal to the element in the next position, which is the integer 2. And then we're going to do it a 3rd time. We're going to print the element in the last position. So this is going to print out the elements in the container in order. Okay, this is an example of one of the loop constructs in C++. This is actually something called a range for loop. Right, so many languages have something like this. They often call it something like for each, or something like that. And the way we write it is, so for type name. So this name is valid only within this block. It's like assigning a name, a temporary name, to each element of the vector so that we can manipulate it inside this block. And the manipulation in this case is just printing it out. Oh, I've got lots of frowns in the audience. I like this. Everything was easy up till now, wasn't it? No. Right, so this says I want to do something for every element in my vector, right? We're going to loop through n times, where n is the number of elements. So in this case, 3. So we're going to perform these instructions, which is in this case just a print statement. We're going to perform these instructions for each element in the vector. Right. And what I'm going to do is create a temporary variable the first time I go through, initialize it from the first element, print it out, throw it away, create the variable anew, initialize it from the second element of my vector, print it out, throw it away, create the variable a third time, this time from the element in the third position, print it out, throw it away. My element only has 3 vectors. My vector only has 3 elements, so this is going to execute 3 times. You're looking very perplexed.
And now I'm just working it out in my head where it says it's going to execute 3 times.
Yes.
And is it going to print 3 times? It's going to execute, just print the whole result, which will be 1, 2, 3, because it's in the print.
It's going to print. It's going to print 1, then it's going to jump to the top, and then it's going to print 2, and it's going to jump to the top, and it's going to print 3, and then it's going to go, okay, this element has 3 vector. This vector has 3 elements. So now I'm done, and then it's going to continue with the rest of my code down here.
So the output will be 1, 2, 3.
It'll be 1 space, 2 space, 3 space, but the final space is invisible. So you've got a hand up over there, yeah.
And it automatically just initializes at the 0 position and then runs through to the end.
That's exactly what it does, yes. Yeah. Sorry? The I is just a name we're giving to that element just for the purposes of having a name that we can refer to it with. I.
So it's not a standard.
No. So I, it can be any name. It can be pink elephant if you want it to be, right? Just I is nice and short, represents an integer. But yes, you could say for int pink elephant in my vector, standard C out, arrow, pink elephant.
But you do tend to see I quite a lot for loops. It's an idiom.
Yeah.
That's get used a lot.
So as I mentioned, this is an example of a range for loop. So there are other loop constructs in C++. There are other ways of writing this, but this is really convenient when you have one of these container classes. So something which meets the requirements of the range protocol, if you like. It's not quite the right terminology, but more or less. And all of the standard library containers, including standard vector, can be used with this this kind of range for loop. So for each iteration of our loop, that is each time we run the body, we're creating a variable I that holds a copy of the element in that position.
Why would you do this instead of just a straight print?
Because you cannot just print a vector. You cannot just say SDE : arrow my vec. And really don't try it, because the error message you'll get will be hideous, and you won't. Yeah, there is no. You cannot just print a vector, unfortunately, in C++. So we have to write a little loop that prints out all the elements for us. But if you wanted to, in fact, it might have been a nice exercise to put this in a function called like print vector or something. So a vector is a collection of things. We can insert things of the same type, I should say. We can insert new things in the back by using this command .pushback. We can ask for the vector size, that is the number of elements, with the command size. We can access elements in a fast but unsafe way using these square brackets, or in a slightly safer way with this .at command. And we can iterate over the elements of our vector. That is, we can perform some action for every element in our vector using this for loop. It's range for loop. These are kind of the fundamentals of, well, using collections. Most useful data structure that you will find. And again, every programming language will have some version of this. Sometimes it's built right into the language, Python, for example. Sometimes, like in C++, this is like some sort of library type. It is in Java as well. But every language has some version of this, and it's important to get to grips with it as early as possible. So here we are in week 3, introducing vector already, which is a lot earlier than some other C++ classes will do it. But as I say, I think it's really important to get you to the stage of being able to write useful programs as quickly as possible. And then, once we're at that stage, then we can start making them better, essentially. But I want you to be able to write useful things as soon as we can. So vector is one of those ingredients that is, or some sort of collection type is necessary for writing pretty much any non-trivial program, and vector is the one you should be using in C++. So we got 15 minutes to go, 14 minutes to go. So I have a little exercise for you, which I think will probably take the rest of the time. So we'll do this exercise, then with a couple of minutes to 5 minutes to go, I'll show you my solution. We'll briefly go over that. And then I've got also a homework exercise, which is a bit more about using vector. So then as you walk out, I'll put that on the screen, and you can take photos or whatever you like to do to give you a bit more practice, again, of using vector. Which actually, in slightly tricky, or the homework is slightly tricky. I'll talk about it later, or the extension is anyway. But anyway, here's an exercise I'd like you to do. Is just to get started using vector, get comfortable using vector, get used to what it looks like in your source code. So first of all, you've now all got C-line installed. So you can create a new executable project. Now I want you to create a vector of strings called names and initialize it with the people on your table. You're all quite spread out, so you've only got a couple of people on each table, but don't forget to include your own name in there as well. And also don't forget to do this #include vector at the top of your source code. The compiler actually, they're all very smart these days, and it will give you a message saying, you forgot to #include vector. But I thought I'd add that as well. Then I want you to use the pushback command to add the names Tom, Ollie, and Michael to your vector. And then, two things. Actually, print out the number of elements in names, that is the number of elements in your vector. And finally, use one of these magic for loops. Oh, I've given it away, but I'm sure you already guessed it. Use one of these for loops to print out each name in your vector. Okay? So I'll give you 10 minutes or so to have a go at that. If you have any problems, as always, raise your hand and we'll be around. There is a little bit difference. The string has a few more convenience functions and also uses
So like if this
some small buffer utilization. So effectively, the vector will always allocate, the string might not allocate, just a small buffer. There is a cost to that as well.
So that would be like decision tree. Yes.
Decision
Yeah.
decision tree comes from machine learning.
Right.
So under the hood is technically a lot of decision tree uses clever techniques. You decide that you actually between one. Well, in machine learning, you need to know, for example, if you have, let's say,
Straight.
let's say you want to classify into man or women, you need to know where to find the cutoff. If you say, okay, if you have this side, you are a man, if you have this side, you are a woman. So they use, for example, entropy, deciding what's the perfect cutoff.
Machine decides what
The machine, if the machine is trying to maximize or to minimize the loss, so it's trying to find and
We have printed that side.
how many shortcuts can I make? How many longcuts can I make?
that's the machine doing that wrong on us.
And then instructions.
That's algorithm.
And then we do
It's completely distinct.
Different from
Yeah.
No, we need.
So if you are
I'm not sitting right in front of you, just
No, so just to be clear that this is
Yeah,
this
not
is
size,
that.
yeah.
Right, okay.
What do you want to do?
people who don't know much about machine learning.
You know the size.
So you want, what do you want to do with the size?
Yeah, no, well, because I just did that, didn't I?
I'm looking this that way.
Okay, no, that's helpful to know. That's lovely.
So you can get this much. What do you want to do with it?
So it's now.
So you can get the size and you can give it back. I remember. That doesn't do anything on its own. That's how you do it.
It's not.
Yeah, the old file bit is doing it.
Keeps a little cursor. Look, that's what happens.
Well, I just really
It's one of those records that you say.
Fair enough, fair enough. I hope this wasn't too like. Is it? I think yesterday.
I'm not sure if you.
How did you think going?
I want to do this. Yeah.
Oh, is it? Oh, okay. Oh, I didn't know it was a month.
Yeah. You give it
Thank you once again for hosting us. I do appreciate it.
You know, I'm trying to see the main function as like a target. And everything that happens inside the story.
Yeah, it's okay. It's already been done. It's been doing it all the whole month. It's good.
I said
I was going, I wanted everyone to get really social and start chatting to their neighbours and stuff. Okay. Yeah, because initialization is simple as possible. Try to make it as simple as possible. But yes, you are allowed to commit people to start. You still get what's called list initialization. So this is a list of names and but for a vector, you may commit still get list initialization. It's a mess. It's a mess. There's no getting around it. I've tried to make it as simple as possible for the purposes. We thought it was a good idea, well, but it turns out there were good reasons for it, because beforehand there was no way, there was actually no way to initialize it. All you could do was create we had a question, that's actually quite a bit of so, yeah, they introduced a thing called list initialization. It's got some quirks, as you've just found out. So I try and keep things as simple as possible, but the truth is it is pretty. At some point I'll have to delve into it in this class. Yeah. So this syntax with the equal sign has been valid since the early days of C for using something called an aggregate, which is a social subset of
It's generally safe for that you don't use numeric model to have this range.
I mean, I got the options.
So, for instance, if you run it now, you should actually go
Oh yeah. And then print out the string in code separated by the line, hash
So,
You don't listen.
actually, this is something I was hoping people were going to discover. Perhaps somebody else can tell me the answer. Can we add multiple things in one pushback statement? No, you can't. No, you have to push back each of the names individually. Exactly that. Yeah.
Why can I can slash for this thing with SE and EL, but I cannot concatenate the string, which does work with the slash n.
Okay, so it's a good question. Right, so if you do the +/n,
That's like concatenation of
that's exactly string concatenation. And that works because name is a string and the /n in single quotes, that's a character. So what happens when you take a string plus a character into a new string, which is your original letters with this new letter repeated? So what you're effectively doing is printing out this new string that you've created. Okay. STD endl, well, what it is a bit weird, but the one thing it isn't is a character. So what you're trying to say is concatenate a string and this weird endl function. And it doesn't know that concatenation doesn't exist. It doesn't know how to do that. So if you actually try and run that, it'll give you some hideous error message. Yes, it looks like that.
But shouldn't it result to end line character anyways at the end of the day?
No, because the endl actually does two things. It inserts a new line into the stream, but it also does something called flushing the stream, which says, so usually the way this cout works is it builds up a bunch of data, like in an internal bit of memory, and then it writes that, asks the operating system to print that out all in one go. Because that's a lot more efficient than doing it with one character. So it builds up a couple of kilobytes of data and then writes all that out in one go. Because that's a lot faster than
Is this like a batching process inside of that?
buffering is what it is, yeah. And but what you can do is you can say, okay, just print out what you've got now. It's called flushing. So we empty all of our temporary storage and just print that out. And STD endl is a side effect of inserts a new line and it flushes the string. So if you do endl all the time, you're going back to the slow way of doing it, which is like writing out one thing at a time, slowly. With /n, it just lets it build up this nice big buffer and copy it all at once. And it's going to get all faster.
Okay, does /n work on all the systems?
Yeah, so
Even on Windows?
so so you know this that different systems have different line endings. But basically, yes, the /n is converted into whatever the system is. Actually, it has something called a, so you can open streams either in text mode or binary. And text mode, basically the only difference is that text mode do this binary mode just literally writes out what's happening. So, how long have we got? Oh, we haven't got any time.
Thank you.
No problem. I love that little thing. Is that a tablet?
Yeah, that's an iPad.
It's not. Oh, wow.
Because that thing is very, very heavy.
I didn't think you were allowed to install computers.
You can, so I guess like for now I'm good. Like I do have Mac with
Well, no, you seem to know what you're doing, so. Hey.
I've got everything the wrong way around.
The wrong way around. Sure. No. All right. So.
Oh, okay.
So now this is a STD vector of the STD string. So rather than call it strings, we can call it strings. So the vector strings, which is Adam for Mitch, and then we're going to, so we've got 3 things in, and we're going to push back Tom. So each name in our strings so this now will do exactly what you want. So you can't do this, you can't access multiple elements at the same time. But what we can do, so you've actually got like the core of that almost completely. So well done. So this is creating a vector of strings. It has 3 things in it. And then we're adding a new thing onto the end, which is Tom. And then down here we'll say, okay, so for each string, for each name, you have strings of which you want to print out space by space. Yes. That's a bit easier. Control copy and paste.
So you don't, these still all, they're still all captured within this line of code.
So we've got a few separate things going on. So first of all, we're creating strings, which has 3 elements in it to start with. Then we're adding a new thing called Tom. Then we're adding a new thing called Ollie. Then we're adding a new string. So we're going to end up with 6. Something broken. Okay, I do have to wrap up because we're a bit over time. If you wait for just a couple of minutes, or maybe Ollie can How have you gone over here? Easy. Awesome, well done. Sorry, I do need to wrap up because we'll get told off if we stay too long. Sorry. I'll come along, so just hang around afterwards and I'll come and have a look. Okay, so I think actually quite a lot of you managed to get that working. So very well done. Here's what my solution to that looked like. So I don't have any people sat at my table, so I just invented some names. So we've got a vector of strings, named names, Arthur, Beatrice, and Clive.
Shouldn't you have included that with the string?
Oh yes, I need a hash include string at the top as well. Thank you, Tom. And we're going to push back the name Tom, push back the string Ollie, push back the string Michael. We're going to print I have, and then we're going to request the size of our names vector. So it's going to print I have 6 names. And then, as most of you did, we're going to use one of these range-based for loops to iterate over every name in our vector. So for each name in names, where the name has type standard string, we're going to print out that name. So it's going to print out Arthur, Beatrice, Clive, Tom, Ollie, Michael in that order. So this was a solution that I wanted from you, obviously with your own names in the initial vector. But just walking around, a lot of people managed to get that done, so very well done to you. I will leave you, in fact, with a fun little bit of homework. So if you want to take a picture, I do, feel like a celebrity now. Cameras everywhere. Have a go at this. You'll have to do a little bit of reading online about standard C-in. So C-out is the output, character output, C-in. You might imagine character input. You might have to have a read about how that works, but part of this is to encourage you to do your own reading, and to do your own practice. So I want you to print out the mean, median, and if you get to it, it's a bit harder, but if you get to it, print out the mode of a sequence of 10 floats. So if you're coming along on Thursday, please do come along on Thursdays if you can make it. Ollie will be downstairs probably going over this problem. And others, and whatever problems you want to bring. Really keep practicing your programming. Right, you don't get better at playing a musical instrument by reading music, by reading books about musical theory. You get better at playing a musical instrument by practicing, and it's the same with programming. All right, that's it. Thank you very much. See you all next week, I hope.
Thank you very much to Christian.